Alright, today I'm going to take video number 2 in the data sharing video sequence, and we're going to look at another paper from a little more than 10 years ago where we embedded an Excel file in the supporting information. It's not really embedding, we just provided it, and we're going to have a look at what can be done with it. So this is going to be somewhat of a data sorcery paper. And so let's have a quick review of what we did in this paper. This was a systems modeling paper where we looked at several different objectives. You want to minimize capital cost, minimize energy penalty, and you can use different solvents for that in a CO2 capture. So we ran probably like hundreds, if not thousands, of Aspen simulations for 3 different solvents. MEA, DEA, and AMP. Those are monoethanolamine, diethanolamine, and I don't remember exactly what AMP is, aminomethylpropanol. We had an Aspen model that looked something like this, and we ran lots of them. You can see some figures here. So this required some integration with a software package and Excel and Aspen to run and get all of the data. Alright, so if I scroll down to see how much data, or like what is available in our supporting information, all it says is the following are supplementary data. So I'm going to go ahead and download this, and let's go ahead and open it. And you can see here that it is literally just a spreadsheet. There are some sheets, and there's some a figure here that has a surrogate power plant model, only an example of a CapEx cost. And so what we'll try to do is see if it looks like we can make at least most of, let's say, figure 4, which is a plot of capital cost in millions versus net power output. So let's see, this has the 3 solvents in it. So I have a sheet here for AMP, and if I look across the top, we're looking for net power and capital cost as columns. There are a lot of columns. We have a CapEx, CampX. You could kind of already see that we didn't make anything easy for ourselves. So we don't have something that is obviously labeled net power output and capital cost. And there's not units up here. So that's not very good. I'm not going to give this paper a very good grade for data sharing. Let's see, CapEx is in the, say, 2 to 3 million range. That looks like it could be the column that we want. Some missing rows. So it might not be the one that we want. And then I see a Power Max that's in the 360 to 410 range. That might be the column that we want there. Okay, so I'm going to go ahead and I guess close this because I'm going to move it to where I want it. So we want downloads. Let's put this over here. And even though I do this on a fairly regular basis, I frequently do not remember all of the details. Maybe it's read Excel. I don't even remember this. So I'm going to need to give it a name here and maybe a sheet name. All right, so let's start with that. So I think we can start there, and let's try sheet name equals amp. And let's see how that doesn't get me what I wanted. No module, oh, no module named XLRD. All right, let's just go fix that. Data sorcery, indeed. I'm kind of surprised that that's even possible. Obviously, I haven't read an Excel file in a long time, or this is an XLS file and you need it for that, but not for XLSX, which probably uses OpenPixel. All right, let's see if this works again. Okay. I think I'm going to make this a little bit smaller so we can read it. And all right, so we have our data frame. Let's just try plotting some things in the data frame. So I think I wanted power max on this axis, and let's open the Excel sheet for amp, and we're kind of like guessing here. Maybe we'll just try cap X. We're guessing because we didn't provide the code that actually makes the figures. So, and this is going to look terrible. It's kind of a good thing it didn't work. And let's just do blue dots for now. So this still might, oh, it does actually plot. And then I think here, since that's in millions, let's divide it by 1e6. Oh, wrong one. So, all right, let's look back at our figure. All right, so amp, I probably should have made green. It's a little bit hard to tell, but it goes in the, it looks like it could be in this range here, and it goes up to about there. So it looks like it could be right. Now let's add DEA. All right, so DEA, we have to switch to this, and it looks like we have, do we have the same? Here's power max and cap X. Looks like we might have the same columns. All right, so let's do, this is df comma amp. df DEA. This one, I think, can't remember, but let's go ahead and add a label. Okay, and MEA looks like I see a CapEx and I see that same one, so let's assume MEA looks the same too. So MEA, VEA should be red. I can tell something already doesn't look totally right unless we've just need to cap it. But we'll see what we can do in a moment. It's totally possible we're just using the wrong columns. So let's see if that's the case. Plot.xlim, say 360 to 420. I think this is 200 to 600. All right. That actually does look a lot like the figure. Looks like I used different symbols, and the main thing that's missing is the Pareto front. I don't actually know how to make a Pareto front off the top of my head, and so I'm just going to skip that. We have the data, so it probably is possible. And I'm going to also note that this only, like I'd say this is looks approximately right. And it's very difficult to be quantitative and say that it's definitely right because we don't have the actual code that was used. But that's the best that I'm going to be able to do in this particular one. So let's see, I guess we could try this I think BO, and then maybe I have to write fill color. Let's try this and see if that makes it look like an open circle. I don't even know that we used Python to make this figure before. Marker, fill color. Unfilled markers. All right, marker, face color. I wonder if that would be MFC. All right. And then we used a red triangle. I wonder if none works. No. And then a green diamond. MFC is short for marker face color. Looks okay. Maybe we should like also set alphas. Make these a little bit transparent, or a lot. And that's kind of getting there. Let's also just change the figure size. Let's see, that's not quite square. That looks like, I don't know. That looks pretty close. And what the heck, why not? Python, Pareto, front. All right, I can try this fast enough. Actually, don't know how we calculated that Pareto set before. Let's see, values array. Hopefully it's not a disaster to print that. Looks like it could be. True. All right, so that's just a mask. So now let's do plot.plot. Let's see what that mask selected. don't see anything at all. Let's just see where is this thing printing or plotting. Oh, it's not doing what I thought. Ah, 0. Okay. So I see true, false, false. I thought that this would have selected some. Like an array. So let's see if it works on the array. No. Hmm. Let's see. I think these not a numbers probably suggest there are not a number things in there. So let's go ahead and see what happens if we drop empty rows. Alright, so we're just going to see if we can do this. That does look a little bit like it, so I think that's probably the issue. So let's just come down here. Alright, so I think what's happening in this Pareto thing is we have these two columns, power max, capex. We're looking for a Pareto in the sense that we maximize power while minimize capex. This gives us a mask. Then we apply the mask to those columns. That works when we have eliminated all the not a number empty columns. And so now I think we should have something that is going to look pretty close to except this one should be a red diamond, a red triangle. Alright, and that does look pretty favorable. We see some differences still. The edge color is black, I suppose, on these, and here I just made them filled. But you can see the Pareto front here. something here, maybe there's one over here, and then we have our red Pareto front over here. Okay, so eventually, with a little bit of data sorcery, I was able to reproduce this figure in a reasonable effort. We still can't be 100% sure, again, because I didn't keep the code. We didn't provide the code. It was 10 years ago. I'm not even sure that code exists anymore. So I guess I would give this paper on data sharing like probably about a C. There is data. You can figure it out. It's missing a lot of things like units, and there's a lot of data that isn't used in the paper, but very little explanation of what they are or how you might use them. It's not obvious that it would help anybody in particular. So this is an example of a paper that isn't that great on data sharing, but might help somebody down the road if they're trying to figure out, you know, whether their simulations are giving the right numbers, and there's a bunch of things that they could look at and compare to. So I think that's all for this one, and next time we'll see an example that is better, I hope. Thanks for coming.